Let us build the model for predicting housing prices in California using Microsoft Azure ML. Azure ML is a collection of services and tools intended to help developers train and deploy machine learning models without writing code. Go to studio.azureml.net and log in with your Azure account. If you don't have an account yet, you can just sign up for free. Let's follow the machine learning checklist to build the model. First, we'll look at the big picture, which involves framing the problem and selecting the performance measure. This is a supervised learning problem, so the performance measure can be root mean square error. Next, we download the data, convert it into the form which machines can understand, and then we split it into training and test set. Let's get the data. Download the housing.csv file using the link displayed on the screen. Now go to Azure ML, click on the dataset, click on New and upload the housing dataset from your local machine. Now click on Experiments and create a blank experiment. Here, you will see a canvas where you can drag and drop various services to train your model. Name the experiment as Housing California. Now drag your dataset. Click on Visualize to see the data. Next, drag the select columns in dataset and join it with the dataset box. Click on Select Columns in the dataset box and click on Launch Column Selector. Here, select all the columns which you think are required for training the model. Let's select all the columns for now. Next, drag split data and join it with select columns in dataset box. Click on Split Data box and split the data into training and test set in 80-20 ratio. Specify any number as a random seed. Set stratified split to true and select median income column for the stratified split. Next, we explore the data to gain insights and remove data quirks. Select on Dataset box and click on Visualize to visualize the data. Next, we prepare the data for machine learning algorithms, which involves data cleaning and feature scaling. Let's clean the training and test set. Drag clean missing data and join it with training and test set. Select cleaning mode as Replace with Median. Please note that we can replace missing values with median only in the numerical columns. Let's select the numerical columns for both the clean missing data boxes. Click on Launch Column Selector, select No Columns and select Column Names. Select all the numerical columns. Do the same for test set, clean missing data box. Now, feature scale the training and test set. Drag normalized data and join it with clean missing data boxes. Select the transformation method as z-score, which is standardization. Next, select the columns for standardization. Please note that feature scaling of the label is generally not required. Next, we try different models and shortlist the top 3 to 5 most promising models. Let's try linear regression and boosted decision tree regression algorithms. First, try linear regression algorithm, drag linear regression and train model. Join linear regression and training set normalized data with train model box. Click on train model box and select label as median house value. Also, cross-validate the model. Drag cross-validate model and join it with train model and normalize training set. Select the column as housing median value. Let's run the steps. Now, select Cross-Validate Model box and click on Visualize to see the root mean squared error of linear regression algorithm across all the folds. As you can see, the root mean square error across all the folds is approximately 68,000. Let us see if we can find a better model. Change linear regression to boosted decision tree regression and let's run the steps again. The root mean square error of boosted decision tree regression algorithm is approximately 47,000, which is a lot better than the linear regression algorithm's root mean square error. Let us select the model generated by boosted decision tree regression algorithm for hyperparameter tuning. Next, we improve the model by fine-tuning its hyperparameters. Drag the tune model hyperparameters and join it with train model and normalized training set. Select the column as median house value and metric for measuring performance as the root mean square error. This step gives us the final hyperparameters tuned model. Let's evaluate it on the test set. Drag score model and join it with normalized test set and tune model hyperparameters. Next, drag evaluate model and join it with score model box. Let's run the steps. The root mean square error on the test set is approximately 70,000. If you are happy with the results, then you can deploy this model as a web service. AzureML gives this functionality out of the box. With web service, you can call this model from your mobile app or web application. Select the model generated by Tune Model Hyperparameters box. Click on Setup Web Service and select Predictive Web Service. Click on Run, and after the run is complete, click on Deploy Web Service to deploy the web service. Here, you can see your API key and API help page. Open API help page. Here is the HTTP post URL, and below are the sample codes in C#, Python, and R, using which you can call this API. Hope you like the project and happy learning.